Right now, we're talking about a very high-level concept on the digital SAT. On the test, you need to be able to employ the factor by grouping method in some unexpected situations. Remember, there's no such thing as luck on the SAT. You got to work at it, and you've got to use instruction that highly aligns with what's on the actual test. Now, to get the most out of this video, you're going to want to try the questions before you watch the video. One way to do that is to use the free worksheet that you'll find in a link at the very top of the show notes. Or you can simply pause the video and try each question before watching the explanation. Here's one practice question to show you where the factor by grouping method usually shows up. In this question, we have an ABC quadratic, and that's compared to a BC quadratic. For instance, let's say you had x squared minus 2x minus 35, and that's equal to 0. Having it equal to 0 is your permission to factor, and when you do that, you would need two numbers that add to the b and multiply to the c. Now this is BC factoring because there's no a coefficient here, just b and c. And of course, the numbers that add to negative 2 and multiply to negative 35 are negative 7 and positive 5. And then you'd use the zero product rule, which says that if these two things multiply to 0, you can set each one equal to 0, because the only way for two things to multiply to 0 is if one of the elements itself is equal to 0. And you would continue from there. Now that's BC factoring. For ABC factoring, you need two numbers that add to b, just like before, and multiply to AC. So for us, in this example, we need two numbers that add to 11 and multiply to 2 times 5, which is 10. And those numbers are 10 and 1. So then you break down the middle term, 2x squared plus 10x plus 1x plus 5 equals 0. And now we'll use the factor by grouping method, which you'll see throughout this video. You take the first two terms and you find the greatest common factor, the GCF, which is 2x for 2x squared and 10x. And after you factor that out, you'll be left with x plus 5. Then you look for a GCF for the next two terms. And for x and 5, there's no true greatest common factor, but we can still factor out a 1. And if we took out 1, then we're still left with the x plus 5. But now we can look at this as two terms, the pink one and the purple one, and they both have a common factor of x plus 5. So if you factor x plus 5 out of this piece, it comes out leaving you with 2x. And if you factor x plus 5 out of this piece, it leaves you with 1. And from here, we would do the zero product rule, which says that if two things multiply out to 0, then that could only have happened if one of them were 0. So you set each piece equal to 0, and you solve them both as individual algebra equations. And therefore, our answer here would be A, negative 5 and negative 1/2. And now let's go over to a higher level example of this situation. Here, we have two functions, and whenever you're asked for two functions and you're asked for the solution, really, you're being asked for the intersection of the functions. And when you're asked for an intersection, you want to get both equations in the y equals format and set them equal. So x minus 20 equals x minus 20 all squared. Now, common sense would tell you that you can just divide both sides of this by x minus 20. We're not going to end up doing this, but just demonstrating here. Now, this would cancel, leaving you with 1. And here, you'd be left with a single x minus 20, because we had two of them right here, x minus 20, x minus 20. And we're dividing 1 out, so it should leave us with a single 1. In this situation, now, if x minus 20 equals 1 and you add 20 to both sides, you'd get x equals 21. But guess what? That's not one of the answers. So canceling out doesn't always work. In this situation, what's happening is this is a situation with two answers, and by canceling one of the x's out, you could be losing one of your valuable solutions. So this entire video is about how to find that other solution, which is the one that would have canceled out if you take the easy way out. So now the other thing we could have said to ourselves as opposed to canceling is that this is a quadratic. And quadratics are generally solved by getting everything on one side equal to 0. So if I take away an x minus 20 from the left, it's going to leave us with 0 equals x minus 20 squared minus x minus 20. Now we have two terms, this pink one and this purple one, and they both have a common factor of x minus 20. So let's factor out the x minus 20. And what's left? Well, when we divide this term by x minus 20, one of the x minus 20s cancel, leaving us with another x minus 20. And when we factor it out of this term, x minus 20 fully cancels, leaving us just with that minus sign. And of course, the invisible number 1, because when something cancels by division, it leaves you with a 1. If it cancels by subtraction or addition, it leaves you with 0. So here we have a minus and a 1 right there. So that brings back the other answer choice that we needed. Here we have x minus 20 and x minus 21. Once again, the zero product rule is the idea that these two things are multiplying out to give you 0, and that could only have happened if one of them was actually 0. So we'll set each one equal to 0. X minus 20 equals 0. X minus 21 equals 0, and you get your two answers. You get 20 here and 21 there. So, of course, the answer that's available to us is 20, which is D. Now going to our next question. Here we have a similar situation. We don't want to divide both sides by x minus 15 because, as I said a moment ago, we'll lose one of our answers. So we say to ourselves, this is a quadratic. What's a quadratic? It's an equation with x squared in it. And you want to remind yourself from time to time that to solve a quadratic, you have to get everything on one side equal to 0. So if we subtract the x minus 15 to the left-hand side, we'll end up with x minus b, x minus 15, minus another x minus 15 equals 0. So now here we are with two terms. Here's one of our terms, and here's the other term, and they both have a greatest common factor, a GCF, of x minus 15. So let's factor that out. So x minus 15 is coming out. When you divide the orange piece by x minus 15, you're left with x minus b. And when you divide the green thing by x minus 15, well, there's a minus sign on the outside, but you're left with the underlying number 1. And now you have your zero product rule because these two things multiply together with an answer of 0. That can only happen if one of them is 0. So we'll set each one of them equal to 0. And we can go ahead and add 15 for the first one. And we can add b and 1 for the second one. So 15 is one of our answers, and b plus 1 is one of our answers. And so the answer to this question here is C, options 1 and 2. And now for our last and most challenging question. The first part of all this is looking at this and identifying that that is a situation where you should use this factor by grouping method. And that situational identification comes from what we're doing right now, which is practicing repeatedly. Don't be one of those people who feels like they can just kind of see everything they need to see once and be ready for the SAT. It's fully clear to anyone who works on SAT full-time that every time they redesign one of these tests, they're making them even harder. So if you want a top score, you really have to put in the work, and therefore you'll be ready when those situations come up. So here, let's do our method. Let's get everything on one side equal to 0. And so we can say 0 is equal to everything that we already had on the right minus the x minus m squared that came over from the left. Now we have two terms, and they both have a factor of x minus m. So if we factor out the x minus m, it leaves us with m minus 5b minus 1x minus m. Because from this part here, we're factoring out one of the x minus m's, but it's still leaving us with one more. So now the next thing to do is to go ahead and distribute that minus sign right there. So we'll have m minus 5b minus x plus m. And on this side, we have x minus m. And now we have our zero product rule, where we're setting each piece independently equal to 0. X minus m equals 0, and the other part equals 0. But let's go ahead and combine the like terms. 2m minus 5b minus x equals 0. X equals m, but solving on the right, x equals 2m minus 5b. So really complicated stuff right now, and it's going to get more complicated because the sum of the solutions times 2 is equal to an expression. So what's the sum of the solutions? That's m plus 2m minus 5b. That's the sum of the solutions. And that times 2 equals 6m plus 4b plus 3. So now we can combine like terms on the left, 2 times 3m minus 5b, and distribute the 2. 6m minus 10b equals 6m minus 4b plus 3. If we subtract 6m from both sides, it'll fully cancel away. And now we have negative 10b equals negative 4b plus 3. Now we can maybe add 4b to both sides. Negative 6b equals 3. Divide by negative 6, and we'll have b equals negative 1/2. And that's our answer to this incredibly difficult question. Thanks so much for watching. Grateful has a library with thousands of free questions helping you get ready for the digital SAT. You can get ready for the entire SAT only using YouTube lessons from Grateful and get a top score at that. Thanks so much, and good luck.